All right, this is Algebra 1B Part 1, Unit 3, Polynomials and Factoring. And we're going to be factoring Lesson 7, ax squared plus bx plus c. Basically, what this is factoring trinomials where the leading coefficient, the number in front of the x squared, is something other than 1. Okay? When there's a number in front of the x squared, it makes it quite a bit more complicated. And it's kind of like solving puzzles. I don't know if you like solving puzzles, I think you'll like this lesson. If you don't like solving puzzles, yeah, you'll bear this lesson. All right, so I've got two examples to work for you here. Here's one, 2x squared plus 11x plus 12. Now I will start this out by saying not all trinomials factor evenly. Not all trinomials factor. And so the trinomials we give you will factor, but it is actually generally accepted that most trinomials actually don't factor. And so there need to be other methods, such as completing the square or the quadratic formula. But factoring, it works out really nicely when solving equations, so it's a useful tool. So here's the way we work it. We write two sets of parentheses right here. And we're going to factor it into two binomials. On the left side, I'm going to list the factors of 2. Factors of 2 are 1 times 2, and that's about it. Okay? Then on the right side, I'm going to list factors of 12. Factors of 12 starting with 1. 1 times 12, 2 times 6, and 3 times 4. So these are the numbers I have to work with for placing in the first place and in the last place in the binomials. Notice a pair of numbers on the left, and I've got 3 pairs of numbers on the right that I'm going to position. The numbers on the left I'm going to position in these first 2 slots, right? And the numbers on the right I'm going to position in these second 2 slots. And really it comes down to guessing and checking. Okay? So here we go. I'm going to guess and check this way. I'm going to say, well, I only have one pair of numbers to choose from, so I'm going to choose 1x and 2x. 1x and 2x. 1x times 2x makes 2x squared. So that's going to satisfy the first term of the trinomial. The last term of the trinomial needs to multiply to make 12. Okay? So we can pick any one of these. So I'm going to try 3 and 4. 3 and 4. Okay? And here's how we check to see if it works. Now remember, when there was no leading coefficient, we just looked and said they need to add to make 11. And that's still true, but what needs to add to make 11? The middles and the outsides need to add to make 11. The middles and the outsides. So we're going to multiply the middles. 3 times 2 is 6. And 1 times 4 is 4. And 6 plus 4 is 10, not 11. So I know that this is not the right combination. Okay? So I'm going to go on and try something else. One of the things you can try is switching the order. Instead of 3 and 4, try 4 then 3. That's a valid switch, and it'll change what numbers get multiplied by what numbers. Let's check it out. 4 times 2 is 8. 1 times 3 is 3. 8 and 3, oh, they do make 11. So lo and behold, they make 11, so I have stumbled on the right answer. Now they need to add to make positive 11, so they both need to be positive. And my solution is x plus 4 times 2x plus 3. Okay? All right. So let's do one more. Let's do one more here. This is one of those things where you just have to practice it a bunch of times. So here's the problem I've got. 3x squared plus 17x plus 6, or minus 6. Okay? So again, I'm going to write 2 sets of parentheses. And on the left side, I'm going to list the factors of 3. They are 1 times 3, and that's about it. Factors of 6, starting with 1. 1 times 6, 2 times 3, and that's it. Okay, so in this first place, I'm going to put 1 and 3. One x and 3x. And then the last place, I'm going to try 2 and 3. Let's try 2 and 3 here. But once again, I'm going to check with the middles and the outsides. I call it the smiley face check. But they need to subtract to make 17. So I'm going to multiply the middles and multiply the outsides. 2 times 3 is 6. 1 times 3 is 3. The difference between 6 and 3 is 3, not 17. So I know that's not the correct combination. Now we can try switching the order. Instead of 2 and 3, try 3, then 2. That's a valid switch. Let's try it out. 3 times 3 is 9. 1 times 2 is 2. The difference between 9 and 2 is 7, not 17. So that's not it. So I've tried 3 and 2 and 2 and 3, so it's not 2 and 3. So we can scratch that off our list. We've exhausted that avenue, that path. And we're going to try 1 and 6. 1 and 6. Okay. 1 times 3 is 3. 1 times 6 is 6. The difference of 6 and minus 3 is 3, not 17. So that's not it. But remember, we can switch the order. We can do 6, then 1. 6, then 1. Okay, let's try it. 6 times 3 is 18. 1 times 1 is 1. Hey, 18 minus 1 is 17. Now we need to get a positive 17. So that means I need the 18 to be positive and the 1 to be negative. That means I need the 6 to be positive. Positive 6 times positive 3 is positive 18. And I need the 1 to be negative. Positive 1 times negative 1 is 1. Negative 1. Okay, and there we go. That is factored. Okay, so have fun. Remember that you're not necessarily going to find the right answer the first try or even the second try. You've just got to systematically go through and try all the options. As you do more of these problems, you'll get better at picking the solution that works earlier on. But you're going to have a lot of false steps, and that's okay.